So let's take a look at some of the salient features of amines in terms of their properties. So first, looking at their chemical properties, we'll look at that in more detail at the end of the chapter, but that lone pair on the nitrogen allows amines to act as a Bronsted-Lowry base, and also as this base that we haven't seen before, this Lewis base. And a Lewis base is any compound that contains a pair of unshared electrons, so any lone pair of electrons. So any Bronsted-Lowry base is going to have a lone pair of electrons. So any Bronsted-Lowry base is going to be a Lewis base. And a Lewis base is just considered to be an electron pair donor. And both of the examples here of ammonia and methylamine have the amines acting as both Bronsted-Lowry bases in that they accept a proton from each compound. Ammonia accepts a proton from water, and methylamine accepts a proton from hydrochloric acid. And then they also both act as a Lewis base in that they donate their electron pair to the proton. So on the product side, we see the quaternary ammonium ion and hydroxide for the reaction of ammonia and water, and then below we see the quaternary ion with the anion of chloride. So primary and secondary amines have 2 and 1 hydrogens respectively bonded to the nitrogen. And we know that anytime a hydrogen is covalently bonded to a nitrogen, it can hydrogen bond. So primary and secondary amines can hydrogen bond with one another. And if we look on the slide on the right, we see a graphic of hydrogens on secondary amines, hydrogen bonding with other secondary amines, where the red dotted lines indicate the intermolecular force. And on the left, we see an image of a secondary amine hydrogen bonding with water. So many primary and secondary amines, up to about 6 carbon atoms, are soluble in water because of this ability to hydrogen bond with water. Now, primary and secondary amines have higher boiling points than alkenes of similar size because they're able to hydrogen bond, but they don't have boiling points as high as similar alcohols, because oxygen in alcohols have 2 lone pairs that can hydrogen bond with other hydrogens, whereas the nitrogen only has 1 lone pair. So if we look at these 3 compounds, all of similar molar mass, butane, an alkane with a molar mass of 58 grams per mole, propylamine, an amine with molar mass of 59 grams per mole, and then propanol, an alcohol with a molar mass of 60 grams per mole, all similar molar masses, so the London dispersion forces are going to be the same. We see that butane has the lowest boiling point because the only intermolecular force it has is London. And propylamine can hydrogen bond, so it has a much higher boiling point at 48 degrees Celsius, but not as high as propanol, which can hydrogen bond much more effectively, so it has a higher boiling point, or the highest boiling point, of 97 degrees Celsius. So you would be expected to rank alkanes, primary or secondary alkanes, and alcohols of similar molar masses. So finally, let's look at some other salient properties of amines. As I said earlier, with up to about 6 carbon atoms, amines with about 6 carbon atoms, especially primary and secondary, will be soluble in water due to that hydrogen bonding. And many amines have very strong odors, especially the more volatile ones or the ones with lower molar masses, such as triethylamine. Ugh, it's disgusting. Many of them smell like ammonia, which is very irritating. Others smell like decaying meat or stale fish. And some of the simpler amines are like ammonia in that they're very irritating to the skin, eyes, and toxic. And some of the more complex amines that are found in plants are some of the most poisonous substances that occur in the natural world.